A particular mass of sample of a mixture was analyzed for barium ion by adding small excess of sulfuric acid to an aqueous solution of the sample. The resultant reaction produced a precipitate of barium sulfate, which was collected, filtered, washed, and finally dried and weighed. It was found that 0.4123 grams of barium sulfate was obtained, and we need to find out the mass percentage of barium in the sample. So even though the numerical looks very lengthy, but it involves only two stages of calculation. See here, this is the mass of the sample given. In this one we are trying to analyze the mass percentage of barium, and the hint is given here. After the entire process, we are getting 0.4123 grams of barium sulfate. So what is the formula of barium sulfate? It is nothing but BaSO4. So in this barium sulfate, 1 mole of barium is combining with 1 mole of sulfate, and 1 mole of barium is nothing but equal to its gram atomic mass, which is equal to 137. This 137 grams of barium is combining with 96 grams of sulfate in order to give 1 mole of barium sulfate, whose mass is 233 grams, isn't it? So as here this sulfuric acid is taken in excess, no need to consider this 96 grams of sulfate for the calculation part. So 137 grams of barium can always form 233 grams of barium sulfate, isn't it? And in this numerical, only 0.4123 grams of barium sulfate was formed, and it contains how much quantity of barium? It is 0.4123 divided by 233 multiplied by 137, and this value is nearly equal to 0.2425 grams. So what is the amount of barium present in this particular barium sulfate? That is 0.2425 grams, and this entire barium is being precipitated as barium sulfate by the addition of excess of sulfuric acid. So definitely whatever barium is there in barium sulfate, that came from the 6.977 grams of the original sample. So what will be the mass percentage of barium? The mass percentage of barium is nothing but equal to the mass of barium divided by mass of sample 6.977 multiplied by 100, and on solving this you will be getting the value as 3.476. So that is the reason why our answer is option B. So this is our hint in the numerical. Finally we are getting 0.4123 grams of barium sulfate. So in this we can easily calculate the mass of barium present, and this entire barium we are getting from the original mixture or the original sample. So definitely we can calculate the mass percent of barium in the given sample.